Hey guys, welcome back. So yesterday I alluded to the fact that when we're doing all this cost curve stuff, right, we're really looking to minimize that average total cost and how that is just the flip side of maximizing the total revenues, right, or the total production. So if we wanted to, we could go ahead and we could graph this stuff up here, and it would be helpful if I had all the markers already, right? And what we're going to do is we're going to go ahead and we're going to talk about just the production for right now, okay? So we already kind of know the cost stuff, right? We'll do the cost on the bottom here. Right now we'll just do the production stuff, all right? And so we know that as we add any particular variable input, right, labor or capital or something like that, as we add one more of those, we're going to end up getting more production, right? Total production. Or you could think about it as total revenue, right? Since at the end of the day, what do we do with this stuff? We sell it, and that's the bottom line of the company, right? The revenue. So we start out at 0, 0, right? Makes sense. At 0, we earn 0 total revenue or total product, right? We could say TP or total revenue, all right? Either one, this graph's going to work fine for us. It's just a generic graph. So it's going to start at the bottom, and we think that, right, there's increasing marginal returns at first. So instead of it just being a straight line, it actually curves upward at first, right? So there's a slight kind of bow to the graph at first because of the increasing marginal returns. So increasing marginal returns. Okay? And then at a certain point, right, instead of being bowed out like that, it's going to be bowed out like this, right? So this is going to look like one of those quadratic, no, what's one more than that? Whatever that is, right, with a third. So it's going to be, instead of a quadratic, it's going to be an order of 3. And we're going to have this kind of inflection point at some point that's going to tell us the difference between our zone where we're in the increasing marginal returns, right, where kind of everything that we add is going to give us more total production or total revenue. And it, this, when we add, 2 workers compared to when we add 6 workers, right, that 6th worker is going to be more productive than the 2nd worker, right? So I can to really get this, we can redo this and really have it be bowed out, okay? And we see that adding that 2nd worker does not add too much, right, from the 1st worker. There's not too much, but then adding that 6th worker from the 5th worker, there is going to be a sizable kind of difference there, okay? So there's a zone of increasing marginal returns. There's a zone of decreasing marginal returns, right? And that's essentially saying, the opposite case, right? So if we are over here and we're at, 13 employees and we go to 14 employees, sure, we're going to get an increase in our total production, right? But as we go further and further out, if we now go from 16 employees to the end of the graph, 17 employees, right? There's no increase there at all, right? This point is essentially the same point as that point in the total production curve, right? So there's this notion that, at first we increase the variable output, it's going to increase the total output, but the rate at which it increases the total output is at first slow, so the rate is slow, and the rate at which that's increasing is going to be fast, 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 and then it's going to stop and kind of peak, right? And then from then on, there's just decreasing marginal returns. So for the most part, though, when we add a variable input, the total product or the total revenue is going to increase. All right. That's not to say, though, that these areas are not completely. So these areas over here, right, where the curve goes back down. It's not to say that that does not happen. All right. It does. So you can get to the point where it's just you're losing money or you're losing production by adding more laborers or capital, right? So in the examples on the video, they talked about how people would start bumping into each other at the car wash. And another common example is a restaurant, right? You can add tables, you can add waiters, you can add, cooks and stuff like that, right? But at a certain point, you add more people, you add more tables, and it's going to detract from the dining experience. People are going to bump into each other and break dishes, right? They might congregate in the kitchen and talk too much instead of actually taking care of the workers, of the customers. So there's a lot of different kind of things in terms of this story over here, right? For the most part, though, we just kind of, we stick to this part of the graph, right? In terms of the feasible amount of variable labor to put in, right? Not feasible, but the reasonable, right? You wouldn't put this much in because you would obviously see that this was going to be detracting from your bottom line, right? Be detracting from your production, your revenue, etc. Okay, moving on. So this is our total production, right? Production. Now the other side of this is going to be our cost curve, right? Our total cost curve. So if this is our total production curve, right next to it, I'm going to go ahead and put my total cost curve, right? So total cost, and we know that this is going to be quantity down here. And we know that we start off with some fixed costs. So instead of starting at 0, 0, we're going to start at some y-intercept, right? And then we think that this kind of takes on a similar behavior, but since it's costs, right, that's the other side of revenues. So we would think that it would not look exactly like it, but that it would kind of look like a mirror image of it, right, which is exactly what it does look like. So at first, we have costs that are increasing at a decreasing rate, right? So it's bowed out, it's still increasing, but the rate at which it's increasing is slowing down, right? The slope starts out, stronger at the beginning than it does. It kind of flattens out here, right? And then we get to this little plateau region, and then they start to increase at an increasing rate, okay? So this is where the costs increase at a decreasing rate. And then over here, the costs are going to increase at an increasing rate. All right? And if you want to, you can do the same kind of tests about the second derivative and make sure that, kind of jives with your intuition. All right? Now, why do I have all these extra graphs below? Well, because most of the time, right, we're thinking on the margin. We're not thinking about the total. We're thinking about the next one. All right? And we know the marginal cost curve that's associated with this total cost curve. It's just the derivative of it, and it ends up looking like kind of Nike check, right? And then if we were to do the same kind of thing with the production, right, we would get something that looks like, you guessed it, a Nike check flipped upside down. So it's going to be something like this. Starts up here, plateaus, and then it just goes down, right? And so I want you guys to think about, so this is our marginal product, or we could think about it as marginal revenue, right? As long as the price is the same, it's going to give us the exact same. As long as the price is the same throughout the range of the quantity, give us the exact same figure. So I think it's a lot easier for you guys to understand this as a maximization, right? You're trying to get to this point, and you want to maximize, you want to kind of get to the point where that good that you're producing is going to give you the most marginal revenue, right? And so what I want to make clear here is the fact that this kind of production and the normal situation of production that we're used to is really just the other side of the coin of this cost curve situation that we've been talking about this week, right? And so I'll leave it there for now, and we're going to pick up on this later when we add the marginal revenue curve, or we add the kind of price curve for the particular markets, okay? But for right now, just understanding kind of, the fact that this marginal cost curve, it's the derivative of this total cost curve, and this marginal product curve is the derivative. It's the rate of change, right? It's just the slopes of this curve, right? So the slope here, it starts out really strong, then it goes down to 0, and then it goes back up, and then gets really, really strong over here, right? So I guess, to be entirely correct, this should be 0 here. So we can change that real quick. we'll remove a lot of it. Awesome. So now I want to talk to you about a situation where we have decreasing returns, right? We have decreasing marginal costs, the whole way through, okay? So instead of just having them at the beginning, right, where we had before, so in our old kind of cost curve situation, right, we ended up with the marginal cost, it decreased a tiny little bit, right, but then it increased for most of it. This is really the foundation of our supply curve, right? And it's dependent on these assumptions about, you know, how firms work and stuff like that, right? The fact that as you increase production, your marginal cost will decrease a little bit at first, but then it's going to go up because there's some sort of constraints, right? But actually we see that this is not too much of an exception, right? We see that given economies of scale and given, you know, the nature of financing and stuff like that, that a lot of firms actually have just declining marginal costs throughout their range of production. Okay, so we're going to look at what that does, and then we're also going to look at what a constant returns to scale marginal cost function would look like, right? So we'll do that right here. So if it's constant, that means that it's just a horizontal line, right? And then what we're going to do is we're going to pick two prices, okay? We're going to have a price low, and then we're going to have a price high for both of these goods, okay? Or both of these markets. And what happens, I guess we should have a price median too, right? So what happens when the price is at the P high, right? So the price, we could also think of as, so if the price is constant for all the quantities that we're producing, we can think of that as the marginal revenue, okay? So the price, the marginal revenue, is greater than the marginal cost. So by undertaking this first unit of production, the second unit of production, this third, right, we're going to just keep on producing into infinity, right? So the solution tends to positive infinity. Okay, so that it doesn't really make the kind of clean little profit maximizing, you know, quantity where the curves meet that we're going to be so familiar with and we're going to get a lot of practice with in class. Okay, so but I just want you to think about that. If the price is always higher than the marginal cost, no matter how much we produce, right? Same situation here in this P high. That the marginal revenue is always greater than the marginal cost. So by producing another good, I'm going to increase my revenue, right? And sure, I'm going to increase my costs, but not by as much. And so since, you know, I like money, I want to kind of build the firm up and have it, you know, have a lot of capital so that it can expand, right? I'm going to always just keep producing as much into infinity, right? And so the same thing happens up here when we have a constant marginal cost curve. When we're at P medium, we do get, you know, somewhat of an equilibrium, right? Like technically we get some place where marginal revenue is equal to marginal cost, which is one of the kind of golden rules that we'll need to know by the end of this class, right? That's where we produce. But look at what happens over here, right? Anywhere to the right of that point, the marginal revenue is greater than the marginal cost, right? This is the marginal revenue. So over here at, you know, Q star plus 100 units, right? The marginal revenue is still up there, but the marginal cost is now decreased. So this isn't really an equilibrium or a solution like we would normally say, all right? Lastly, if the price was, you know, just below the marginal cost in either one of these cases, right, there's going to be zero production at all. So for these particular things, we get this strangeness where there's no real Q star, right? That either if the price is sufficiently high, they're just going to produce as much as possible, produce infinity, or if the price is low, they're going to produce zero, right? And that's even when they cross, right? Because it's a false kind of equilibrium there. All right. If you have any questions, I'll see you guys in class tomorrow. Have a good one.